Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 316, remove duplicate letters. I'll be going through my thought process as I come up with a solution, and then stick around for the end of the video where I compare my solution to the solution of others. With that, let's begin the question. I have my whiteboard here. So we are asked, remove duplicate letters. Remove duplicate letters. Let's see. Yep, you can see it here. Medium level question. Given a string S, remove the duplicate letters so that every letter appears once and only once. So essentially, no duplicate letters in the string. You must make sure your result is in the smallest lexicographical order. Okay, smallest lexicographical order. And no duplicates amongst all possible results. So it's not that the string itself has to be in the most lexicographical order, it's the string constrained by removing duplicates has to be in the smallest lexicographical order. What that means is a string that that appears here. Let's look through what it would look like. B, C, A, B, C would be something like A, B, C. Why? Well, there are the letters B and C are duplicates, and we can remove them. Removing them would be pretty simple. We cut these two out, and we're left with A, B, C. All good, right? Another example here. We have the string C, B, A, C, D, C, B, C, and all letters actually, besides A and B, A and D are duplicates. So we have the letters C, B, oh, still C and B are duplicates. And let's see how we can remove them. We can remove C. We can remove C, we can remove B, and apparently, just looking at the output string, we could also remove C here and the C here, which would just leave us with the A, B, A, C, D, B. Looks like A, C, D, B. Okay, so even I had already a bit trouble with figuring out what the solution there would be. Why? Because while removing the letter C, I had to basically be aware of where it should ideally lie in the result. And so there comes the issue, right? The issue is we have these places for characters. For multiple characters, we don't know which one to remove it from. We don't know which place to remove the character from. And so, okay, so with these sorts of questions, how do I start? There's definitely some sort of pattern, some sort of question that I have to be asking myself each time um, I append a letter to my substring. So first of all, I propose definitely starting with, let's say, starting with a substring, and then continuously growing it. Grow it until, grow it while while maintaining some rule or maintaining some uh, property until um, until we're out of characters, right? Until done. So okay, well that's gonna be my it's gonna be my task here. Now just to come up um, with how we would actually go about it. Um, cool. Interesting. So, to the human eye, seeing the first input, I can right away see that, for example, B and C appear somewhere down the path. So, A would sort of eliminate the characters B and C and preserve the characters B and C. So, it's not that A would eliminate, it is good for me to eliminate the first two because they appear somewhere down the path, somewhere down the line, in places where they're lexicographically more better suited. But how do I approach that same with that same mentality? How do I approach example two? Um, I know that C, I know that C, I know that B precedes C in lexicographical order, but I don't know if I can remove C until I actually know that I can remove C, right? Um, until I know that there are other instances of C in the input string. So I definitely need some tuple, I guess, or even set with characters that are repeating and characters that aren't. Because characters that aren't repeating, I can't get rid of them. They serve as the base for my response. But if they serve as the base for my response, mm, how do I know how to orient, how to build my substring if, for example, I'm not on a character right now that serves as the base, right? So, I mean, these are all questions that I'm asking myself right now. I have no idea how I would go about it. Um, One thing that I'm thinking of is um, let's start building this substring as if I don't have anything yet. Uh, Step one, I have C. Step two, I have CB. I'm gonna try to have a couple of rules. The rule is um, characters are not repeating. How do where would I do this? Rule one. Rule number one. Characters don't repeat. Well, characters don't repeat. I would go through this pretty seamlessly. That is easy for me to check. CBA character. Step number four. CBA, CBA. I would skip C. I would add D. Then five, I would have CBA, D, skip C, then skip B again, and then skip C. So that would be my result. However, CBAD isn't ideal. So I need another rule. Let's think of rule number two and remove this garbage. Um, Rule number two. Rule number two. I need to have the substring that I have at the moment has to be always the smallest possible lexicographical. Here's how I'm trying to structure this and why I'm having an issue with it. If I claim that my substring at any moment is the smallest lexicographical version of it, then at which point would I be able to ask myself a question like, can I add another character to it to make it less lexicographically, or to make it lexicographically larger? I wouldn't be able to answer that question ever, because it's always going to be it's always going to be greater, because I'm just adding more characters to it, right? So I guess the question has to be if I can replace, or even at some point make the string smaller even, and then append to it more. So for example, what I'm thinking right now is, let's say that I have this output here, right? A, C, D, B. I could design a rule that would ensure to me that at any point of time, as I'm iterating over the logic, as I'm going through the logic, I may not even have this output string constructed. I can have it partially built, but what I can't have is a version of this output that is, what would it be? A version of this output that is, I wouldn't say wrong, because wrong just means it's not complete. How about this? At any point of time, as I'm iterating over the input string here, as I'm iterating over the input string, I could design a, oh no, okay. Messed up a bit. Oops. At any point of time, I cannot have, while I'm looking at it, I cannot have a string as I'm iterating through the input string. I must always have the lexicographically smallest string with all appearing characters that I've iterated over. So when I look at the first one, there's only going to be one. Okay, so rule number 2, have the lexicographically smallest string without compromising showing all the characters that I've iterated over. So while iterating string s, always have smallest possible lexicographically, while having all the characters. That wouldn't work either, because then how would I create this A ever? At some point I would have to remove C and B entirely, and I would only be looking at the first 3. Okay, so how about, while iterating over S, always have the smallest lexicographically, while also knowing that you can achieve or find these 2 other characters, C and B, somewhere down the line. Okay, so while being sure you while iterating over S, always have the smallest lexicographical string, even if it means removing some. Step one is my first step. I'm going to have two mechanisms. The first mechanism is going to preserve this, is going to make sure that that the string in my current output, the one that I've constructed, is lexigraphically smallest. So we can have in this output, and while it's growing, we can have something like A, C, or even CBA. No, no, no. We can have C, we can have B, but we can't have CBA. A would remove C and B at some point because we know that C and B appear somewhere down the line. So here's how the mechanism that assembles the as it adds to the output string functions. It looks at the next character, and at step one we would just have C. At step two, I have to run through a couple. At step three, we have A, but we know that C and B appears somewhere down the line. That step basically executes another mechanism that, while it's sure that C and B is somewhere down the line, it basically pops these elements, these characters from, let's say, a stack, and replaces them with A. So at step three, we would have had our first portion of the output. Let's look at step four. Step four, we are encountering a C again. So step four, we have a C. Step five, we have A, C, D. Step six, we have A, C, D, and now C. Now, why and where would we encounter C? We would encounter C if it appears anywhere down the line. But how do we know that we don't have to add it anymore? Well, if it's in the stack already, then we just skip it. We skip C. We have A, C, D. We don't skip B at step 7, A, C, D, B. And step 8, we skip C once again because it's already in the stack, and we get A, C, D, B as the result. Okay, so what data structures have I? Hello. My apologies, cut out again. The question here was, what kind of data structures did I refer to while filling out this this output? And actually, I made a mistake here. C. It was on first step, I added C. On the second step, I added B, but what my output should have really looked like was C, B. Then on the third step, I am trying to append A to the output, but A has a specific property or situation in this case that previously didn't happen. A is lexigraphically smaller than both B and C. And so while comparing A to the current output, I can see that A should probably be somewhere towards the beginning rather than at the end. What I would like to do now is check if both C and B are in something called maybe like an available stack. Like, are they, or not a stack even, maybe like just a set, are they somewhere further down the line where I could maybe then utilize them for a better case, right? And I'll get later into a situation where I might actually even want to know where they're located. Um, further down the line, but that's for later. So at this point on step 3, I'm asking myself, or I'm asking the program, hey, I have the character A, can I append it to my output? The answer is no, because because B, which is the current end, is lexigraphically larger than A. I would like to pop it. I'm able to pop it because I know that it occurs later down the path in the input string. And that's it. I That's right. Yeah. It's Hold on. Yes, 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 yes. I pop it because it is lexigraphically smaller than or larger than A, and it does occur somewhere down the line. Cool. Then I do the same thing with A. So this is probably just going to be, sorry, the same thing with C. And this just shows that this is a while loop. Um, so I do the same thing with C. I now have on my third step just A singled out entirely. The next steps go and fill that output with the same situation that happened from steps 1 to 3 happening down the line on steps 7 and 8. Cool. Okay, so with that, I want to, oops, I want to start recording the solution. So we mentioned three different um, data structures. We mentioned a set, which is just going to be a result. We wanted a scene set, which is just going to be holding what is the current, or maybe let's say current result set. What is currently in the result is could be a set, or it could be just this, right? Actually, now that I'm thinking about it, could I even um, just use this for now? I also need to know where my characters appear in last, and that's going to be something called last occurrence. And that is going to be a dictionary where C, which is just a character for I, enumerate S. Let's look at these data structures quickly. Cool. B appears in the third position last, C appears in the fourth, A appears in the 2. I'll get to why I need that later. Now for I, C, and S, I want to essentially do that what I've been doing, looking at each character, seeing if I can append it to the res stack or not, result stack. So let's see, if C not in res stack, meaning that I'm definitely adding this character right now. I just don't know if it's going to be enough to simply put it at the end, or would I have to drop some of the prior characters. And here, while res stack and C is smaller than stack with the lexigraphically smaller, and I is less than, and this is where I'm going to use my my last occurrence dictionary. Stack. So I want to also make sure that the place where I am standing at right now is at least smaller than, or no, it is definitely smaller than the place where this previous character is. Because let's say now that I am at um, A, and I wanted to pop all of these C's, right? Well, the only way that I'm going to know that the C's to the left are able to be popped is if there's at least one C further down the line that I will be able to utilize. So again, res stack just means that while the output string is still present, if it's still there, while the current letter is lexigraphically smaller than the letters to what are in the output right now. And finally, that the characters that I'm removing are actually found somewhere down the line in my input string. And here, that would be it. I would say res stack pop. Cool. And now that I've that I have removed it, I'm going to res stack append, and this is going to be C. That's it. Return is going to be a simple join of the res stack over an empty character. And this should work. Stack is not defined. I meant to say my result stack. I've been referring to it as stack, but it's actually called result stack. Okay, it doesn't want to. Okay, let's print this again. We should see that this is running correctly. However, there's going to be a slight optimization. This optimization isn't needed to solve it, but what it will do is essentially save us this condition right here. So for now, and maybe it's not even needed. It seems like it's even faster. What's happening right now is that each time I'm asking if C is not in res stack, I have to iterate through all of res stack, but I don't actually have to do that. I can use a hashing, property of each character, which would just mean that it would be something like this. Res set, initially just a set. Here I would remove the element popped when I remove the element from res stack, and here I would add C, the character, when I add it. And here now, instead of running through what is a list, I would be running through just a set. And same situation, just a bit faster. So my computer has been extremely slow. Yep, not even significantly faster. 40 milliseconds instead of 42 milliseconds. Cool. Okay, well, I'm going to end it at that today because I'm having some technical difficulties. And I've noticed that it's pretty hard listening to me when I try to think through these things, especially when There's a drawing, and I'm struggling to draw out something that's coherent on a piece of paper, but these things make sense to me in my head, and I'm just trying to see how long it's going to take me for the drawings to start making sense. Okay, cool. Well, on that, thank you for watching, and I'll see you later. Bye.